about engine, okay, is your the strokes that we have that we're talking about. It's called a four stroke, basically means called four steps. Yeah, stroke actually means like step. Okay. Probably girls, I would say females are not so familiar. Maybe boys, you all talk about cars, you all know cars, then probably this is like, okay, I know what this is about. So engines are normal, usual car, right? We should have four pistons. So one engine, like for example, this is the engine in front of your car. You have four pistons, okay? Some cars has three pistons. Nowadays, we have come up with like three pistons car. Like for example, the latest Proton car we have launched in Malaysia, the X50. You know, everyone is so hyped about it. It's three piston. It's three piston, like three. Okay, it's an odd number. Some cars might have six. If you heard of a straight six engine or V8 engine, or you know, the more pistons you have means the more worker you have to work for you as an engine. So usually we have four pistons, and each four pistons, or four, each of them will go through four steps. That's why it's called four-stroke engine. All engine goes through four steps. No matter if you are two-stroke, you are sorry, no matter doesn't matter if you are three pistons or four pistons or six or eight or as crazy as 12, like all the supercar we have, like Lamborghini and the Ferrari and all that. Okay, so hence each of them should go through four steps, which is what we call four strokes. Okay, so we have two types of engine here. We have petrol engine and we have diesel engine. Both share the same steps, but slightly different parts we have. Okay, so I'll go through the four steps with you first. So we have induction stroke, means the starting. We have compression stroke, means to compress. We have power stroke. This is where the steps where it gives power to the engine. Okay, and we have exhaust stroke, which is the last step. Yeah, the last step. Okay, so each stroke, right, has its special function, and each of them has like a different parts that is opening or closing or moving up and moving down. I know to most of you, all four of them looks the same lah, but each of them has their own special parts to look at. So let's start off with the first one, induction stroke, right? Look out for your inlet valve. Your inlet valve is open, petrol air mixture is entered into the cylinder. Okay, open means this thing push downwards, by the way. Okay, and then that's where all the petrol and air mixture comes in. Second stroke, we call the compression stroke, which is to compress. So notice the piston is going upwards and compressing. Okay, your induction and exhaust valves are both closed. Okay, so then you compress the petrol and air. So it becomes very hot. And at this moment, number three, power stroke, we have this thing called the spark plug. Okay, so spark plug creates spark and light up the petrol air mixture. So you realize the piston is pushing down and there's like a mini explosion here. That's when your engine gives you power, like boom, then the piston push down, the piston will turn the crankshaft will turn the drive shaft of the tire or of the wheels. Okay, so that's called power stroke. All right, exhaust stroke, piston going up, exhaust valve is open, pushing the carbon dioxide or the burnt gas out of the engine. Okay, so you see, in conclusion, right, each of them has their special parts to remember one. So by compression and exhaust, both piston go up, but difference is exhaust valve is open for exhaust stroke. Okay, induction, the piston go down, power stroke, the piston go down, but the difference is induction, you have inlet valve open, but for power, both close. Okay, that's it. That's it. So try and recognize those that I highlight for you. Okay, and diesel works the same, it's just slight difference. So let's talk about the difference here. First of all, inlet valve open as usual, but the difference is air. No more petrol, air, because this is diesel. Then you might be thinking, huh? Then where's the diesel? Diesel doesn't go in through the first step. That's how diesel engine works. Okay, so it's just air going in. So then number two, compression as usual. Okay, the piston move outwards and compress the air until very hot. And number three, explosion, piston go down, and you realize this thing, it's called the fuel injector. This is when the diesel is spray into the engine. So you see, the fuel doesn't spray into the engine in the first place. Unlike petrol engine, it goes in the first place. Okay, but this is not. Diesel comes in the third stroke. So this is where the air is so hot, and then the diesel comes in and it burns up, it lights up the whole fuel in all the fuel in the piston. Okay, and then exhaust stroke, same, piston go up and exhaust valve open to push the gas out. Okay, that's it lah, actually, nothing much. The main difference here is air, petrol air, spark plug, fuel injector. Okay, diesel goes in through the third step, petrol goes in through the first step. Okay, that's actually pretty much what we have in the table here. So let me go through with you the differences. So first of all, similarity, but no matter 4-stroke petrol or 4-stroke diesel, both are internal combustion, means the engine burns inside, the fuel burns inside the engine, okay? 4 stages, each of them must have 4 steps, remember, 4-stroke, and both engine convert chemical to kinetic, okay? Chemical, unless now we have like hybrid car, the engine is electrical to kinetic, you know, but usually combustion engine is chemical to kinetic. All right, no problem. All right, so the differences we have, just now we kind of say some of it. Type of fuel, of course, petrol and diesel, you know, like okay. 4-stroke petrol, of course, uses petrol lah. 4-stroke diesel, of course, uses diesel, okay. And next one will be what goes in to the first stroke, petrol and air mixture, but diesel only air. Okay, all right, next one. Way the fuel is ignited, how you start the engine. Diesel start with compression of air in the cylinder, means the air has to be very, very hot. So old school engine like bus and lorry are all one. Morning very difficult to start one because they have to, because the engine is still cold, the air compression is not hot enough. Even the diesel is in, but it doesn't light up. It's very difficult to light up in the morning, especially for old cars and for but diesel engine generally difficult to start up, okay, because they use compression of air. But for petrol engine are very easy one, because we use spark you create fire on your own. That's of course easier. So we use spark from the spark plug. But some old cars also difficult you know, already my mechanism works differently as well. Okay. And next one, we have more pollution, less pollution. So diesel, everyone knows that, of course, more pollution. And then petrol, of course, less pollution. All right, I think we have 1, 2, 3, 4. I think we have 4. 4 is enough. I mean, of course, we can go for size as well. Diesel engine are rather big, like for buses and lorry. Okay, those are bigger engines. Can? Okay, I think we can try one of the questions. So please turn with me to page 38, question 2, my friends, 38. All right. Okay, you know what? I would like you to try on your own because I think it's very easy. You may refer if you need to. But if your picture not clear, you all can look at my screen now. If you're not sure which stage is this. Okay, but let me give you some hints and let me help you start off the question. If you take a look, right, first of all, it's a diesel engine, by the way. It's a diesel engine, okay? And if you realize there's like a mini explosion here, I know it's very difficult to see, but this is also one of your tips or your hint. Your piston is going down. Okay, there's some more on next page. So come, you can start off. I'll wait for you for probably 1 or 2 minutes, and we'll talk about it. Okay. How is it, everybody? Shall we? Okay, so let's take a look. A1, name the stage. So I already gave you the tips. So it's a mini explosion and the piston is pushing down. This will be a power stroke. Okay, power stroke. All right, and identify P. So I was saying that this is a diesel, right? If you know this is a diesel, so you must know what is on top. So diesel, that thing is called the fuel injector. No problem? Okay, fuel injector. All right, next one, arrange the steps. So this is where you have to know the sequence properly. Okay, so let's identify the first one. So remember the first one was induction. Induction means the inlet valve must open. Let's search for it. Inlet valve, there you go. Inlet valve is open. So M is your first one. Okay, right? So then after M, second one is called compression. Compression means the piston is pushing upwards, but both valves are closed. Piston upwards, this one and this one, but both valves are closed. So definitely K, second step, compression stroke. Okay, can? So M, K, J, and L. That's your sequence. Easy cheesy. No problem. Okay, like see. State one difference between 4-stroke diesel and 4-stroke petrol. Okay, plenty of them for you to choose from, right? Did you choose from this table? Any differences you would like to, but please make it to like sentence lah, like a 4-stroke petrol engine uses petrol as fuel, while 4-stroke diesel engine uses diesel. I mean, you can do shortcut now, but in exam, please make sure you write your sentence properly, okay? or you want to go for like a 4-stroke petrol engine is smaller and lighter. 4-stroke petrol diesel engine is bigger and heavier. Okay, no problem. All right, let's draw lines. Okay, this is like a normal boat lah, small boat. So boats like that, right? They use the 2-stroke engine, the small one, like motor like that. Means that it only go through 2 steps, 2-stroke, 2 steps. Okay, so same like motor, lawn mower, the one we use to cut grass, all the simple motor, or motor that use in pasar malam, you know, they use that generator, those are motor. Okay, okay, so lorry, of course, 4-stroke, 4 steps. No problem. Okay, since we're talking about 2-stroke, let's come back for some little 2-stroke story. Okay, I'm not gonna go through like the details, so not super important, but you still have to know the basic. Now, 2-stroke means 2 steps. So first and second step together combine, 3 and the 4th step together combine. That's why it's called 2-stroke. How is it combined? Okay, let's take a look. Well, if you realize that inlet valve is here, inlet is open, okay, exhaust is closed because this piston is actually moving outwards and block the entry. Okay, so this is your first stroke, induction stroke, but at the same time, the piston is pushing up to compress the petrol admixture. So this is also a compression stroke. So induction, compression combined. Okay, so then the petrol will have to wait for a bit underneath. Okay, then the third and the 4th one, when explosion happens, boom, then the piston push down. That's when your exhaust go out as well. So power, exhaust, stroke, both stroke together. And the petrol that came in just now will sneak through this little gap here and then goes through the first and the second step again. So we repeat this. Is that all right? Can? Okay, so no problem, everybody? Okay, just like that, nothing much I want to highlight about. So at least you have an idea. Okay, so then we have the next part, which is calculation, everybody. So speed, no problem. Everyone knows speed already. That was your math. So speed is equals the distance over time. Total distance over time. Yeah. Velocity and speed is very similar, but I wanted to know the difference between displacement and distance. Okay. So for instance, from A to B to C. Okay, let's say this is 3 meter, this is 2 meter. So if question is asking for distance travel, right, your speed will be 3 plus 2 in total 5. Okay, so 5 over, let's say, I don't know how many seconds are we talking about. Let's say, let's make it like a 10 second. Okay, that's how you do the formula for speed. Yeah. Is that okay? Distance over time. But if question looking for velocity, okay, when question looking for velocity, you have to use displacement. Displacement means my starting point and ending point, means A to C. I don't care where you've been through. I don't care if you have went to B or went to whatever. I just want to know the displacement, means your starting point to your ending point. Of course, question will give you lah, but in this case, I don't know what's the number. If you want to know, I think we need to use the Pythagoras theorem that you learned long time ago to find out, right? It will be your a square plus b square and square root both of them. Okay, so anyway, I'll just assume I don't know. I just assume 4. I don't think it's 4. I think it's 3 something. Okay, so then my velocity will be 4 meter over same 10 seconds. The same scenario, but just asking for different thing. You'll get it. Yep, that's the difference of, okay. Usually tricky questions like that will be in your objective. Like question is asking for, okay, calculate the velocity of the car. They'll be like, oh, okay, distance over time. Then you're wrong. You're actually looking for 4/10, not 5/10. A lot of people will go for 5 because you don't remember what's the difference between displacements and distance. Okay, so we go for this one. So same scenario, can be asking different thing and different answer, you know. So make sure you know how to differentiate. Okay, but subjective usually no. Subjective we use we actually do taker timer, so there's not a problem for us. Usually objective is the problem. You have to be careful. Okay, so acceleration is final velocity minus initial velocity. We're using this formula to sub in. Okay, divide by total time. We'll talk about taker timer. It makes more sense in that. So we'll practice the calculation later. Okay, so in order to test all this, we cannot test in science lab with the real car or the real vehicles. So you have to make like a toy car, you know, like a toy version. So we will have a trolley sticking with a ticker tape and going through this thing called ticker timer. Okay, that's what we're talking about now. So ticker timer is a machine used to measure time, distance, speed, and acceleration of an object in science laboratory. So this little machine here enable you to calculate everything. Convenient, okay? The machine that we're using, it's called a 50 Hertz ticker timer. What is 50 Hertz? 50 Hertz means in 1 second, it vibrates 50 times. You heard me right. 1 second, 50 times already in 1 second. Okay, so that's called 50 Hertz. Only one machine that we're talking about here. So what do I mean by vibration? What do I mean by ticks? Ticks are the distance between two dots. Yeah, so this is called a tick. So in this case, in this ticker tape, after the car went down, right? Glung, 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 and then you will get a long tape behind the car, and then teacher will ask you to cut. So the tape has a lot of dots above. Okay, the tape has a lot of dots above, like this one. So this is called 1 tick, 2, 3, 4, 5 ticks. Okay, so from the tape given, we can actually calculate time. Okay, 1 second, the machine makes 50 ticks. So let's do the math. How about 1 tick? It will be 0.02. So 50 ticks, 1 second, 50 ticks. Hence, 1/50, you will get 0.02. All right, how about 10 ticks? Times 10, 0.2. How about 5 ticks? Half of 10, so 0.1. Half of 0.2. Usually we memorize these two can already because questionnaire will always give you either 5 ticks, okay, like 1, 2, 3, 4, 5, or give you 4 ticks. Sorry, I mean, what am I saying? 5 ticks, or it gives you 10 ticks. There's only 2 types. Don't worry about other numbers. So I suggest you remember the number already. 10 tick means 0.1, 0.2, 5 ticks means 0.1. While your friend's still struggling, hey, how where's the time? How to look for the time? Where's the, like, which one? Count what? You already know, 5 ticks. You count yourself, 5 ticks, then you know, okay, 0.1 second. The length is given here. So since you have length or this length of the strip or distance provided, and also the thicker dots that we are able to calculate your velocity and your acceleration. Everything comes from that too. Everything comes from the dots, which is represent time, and everything comes from the length, which is represents the distance or the displacement. Okay, we'll try out the explanation. We'll try out the calculation later lah. I mean, no point I talk so much this one, no use one. We have to try, then you can understand better. Okay, so I'll skip that. We'll talk about the type of motion. Yeah. So after the car went down, right, I'm pretty sure you got a very long tape with a lot of black dots. Then why my tongue is not my tongue today? Then teacher will ask you to cut by, I don't know, maybe 5 takes or maybe 10 takes, depends. Okay, and then teacher will ask you to observe the dots and the pattern. Okay, we have 4 patterns here. So first, we have actually both of these the same. Uniform velocity means the car is not going faster or slower when you see the dots are very uniform. The distance between two dots are the same throughout the whole entire ticker tape. Okay, but this is a slow one because the dots are very close. Okay, because the machine vibrate 50 ticks per second fixed. If your tape go through it slowly, you might get a lot of dots very close. Okay, if you go through it very fast, means you get further distance. Is that okay? So this is high velocity but uniform, both uniform. Okay, the problem is the next type, which is acceleration and deceleration. Okay, always look for the arrow. So if arrow is pointing to the right side, means the paper was pulled to the right side during the experiment. Okay, and hence this is where you should start looking at from. So starting from here, which is very close, means very slow. This is further, means very fast. The distance of the tape, hence this is acceleration. Okay, so from close to further, slow to fast, close, slow, close. I hope that helps. And then further, F stands for fast as well. Okay, so slow to fast. Yep. Okay, vice versa. Pointing to the right means the paper will pull to the right side. Let's starting from here. Further, fast to closer, slower. So deceleration, my friends. Is that all right? So actually, the thing here is the arrow. If you realize if the arrow terbalik, right, then the whole story will be terbalik. So arrow makes a very important point here. Okay, so we shall try out the exercise. So please come with me to page 40, everybody. Oh, no, 39 actually, 39. Okay, shall we? Okay, we have how many strips? We have 5 strips here. And you realize that it's going to the left side, everybody. Take a look at the arrow. So starting from here, we will look at closer. The dots are very close. The dots are very far apart. So this will be slow, this will be fast. So this trolley is moving from slow to fast. Okay, or I shall say acceleration. Can? Okay. So anyways, let's see. You're supposed to measure the length of the 4th and the 5th, but you cannot do that now because your book is being shrunk into 2 pages. You will not get the correct answer. But if you realize based on the number jumps, right, you can realize you can find out the last 2 answers. So 1.8 to 2.2, 2.2 to 2.6, every jump here is 0.4. So 2.6 will be another 4, 0.4 will be 3, and 3.4. Okay, you can't measure now, but in exam you can, because I shrink the page so your measurement is off. You cannot measure the correct answer. Okay, so according to the graph, half of the bar chart is given. You need to complete the 4th and the 5th. So let's just follow. So it's 3.0 and 3.4. So 3.0. Roughly lah, 3.4 also roughly lah. I couldn't get half of it also. Roughly lah, roughly. Okay, there you go, easy. All right, no problem. Okay, let's go to B, everybody. Based on the complete chart, describe the motion. There you go. Describe the motion of the trolley. Like, is it getting faster? Is it getting slower? Is it not increasing, not decreasing? So as we have already talked about it just now, so the arrow goes to the left side. right? So you should be start looking at the left side to the right side. Then you get slow to fast because they are closer, these are further. So slow to fast, that will be increasing velocity, or we shall say acceleration. So you can write the trolley is moving in increasing velocity. Okay, the trolley is moving in increasing velocity. Or you want to write acceleration, you can write the trolley moves with uniform acceleration. Why do I say the word uniform? Is because, do you realize each jump is 0.4 no matter how? Isn't that uniform, like fixed? It's always jumping, it's always increasing at a fixed number. That's called uniform acceleration. Means the car is increasing very steadily, like yeah, it's not like no, that's not uniform. That's suddenly going faster. So that's called uniform acceleration. Okay, can. So either you can write the trolley moves in increasing velocity, or you can write the trolley moves with uniform acceleration. Alrighty, okay, right, let's go to the calculation. So just now I didn't say much about calculation, right? Because we'll do it here together. It makes more sense. Okay, this is how a standard ticker timer question will be, asking for final and initial, and asking for acceleration together. So 3 calculation. Okay, so I cut half. Standard one, they always ask that one. Standard one, I tell you must know how to calculate this. Okay, initial velocity equals to displacement over time, right? Final velocity equals to displacement over time. That's the formula. That's the formula. If you're wondering what I'm doing about, that's the formula, my friends. Okay. Let me write this one more time. Okay. So initial means the first strip, my friends. The first strip. Yeah. The first strip is 1.8 cm, and that's your displacement or distance. Okay, over time. Time comes from the tick. Do you guys remember? Don't struggle. The time is the tick. Be confident. So 1, 2, 3, 4, 5 ticks. 5 ticks is how many seconds? You should have that in your head already. Don't struggle. Like, oh, okay, wait, I need to count. 5 ticks. 1 second is 50 ticks. So 1 tick is then you have to go through the hassle. So just memorize it. 5 ticks, 0.1 second. So my time is 0.1 second. Okay, calculator will do the job, my friends. Please do the last strip as well. Help yourself. I'll discuss with you in a while, okay? All good, right? So 1.8 over 0.1, 18 cms negative 1. Okay, so final is 3.4 cm over 0.1 second. So 34 cms minus 1. Easy cheesy, okay? If you're wondering, what's 0.1? How do you get 0.1? Same lah, my friends. It's 5 takes. Don't struggle, okay? 5 takes, 0.1 second. Fix already. Can? All right? Okay, so there you go. Since you have your final, you have initial, let's move on to acceleration. So acceleration equals to final velocity minus initial velocity, okay, over total time. Is that all right? Okay, final, bring it down. Okay, 34 minus initial, bring it down. Okay, 18 CMS -1. Okay, over total time. Okay, this is where the trick comes in. Okay, I have 5 strips. Each strip uses 0.1 second, 0.1 second, 0.1 second, 0.1. Why 0.1? 5 ticks, ma. Remember not 5 ticks. Each of them 5 ticks. It will use up 0.1 seconds. So I have 1, 2, 3, 4, 5 strips. Each of them 0.1, 0.1, 0.1, 0.1, 0.1. If I were to calculate the total time, I will have to add up all together, isn't it? But because this is acceleration, we are counting time, we go for interval. I have 5 strips, but I am going to -1. Then only I times 0.1 second. Why must I -1? It's interval. Interval means I don't go by 5, I go by 1, 2, 3, 4. If you're confused by this method, this is what you can do. Ask yourself, everyone. 12 o'clock to 3 o'clock. 12, 1, 2, 3. How many hours, everybody? 12 to 3 o'clock. How many hours? That's how you count time, right? And then you realize like, huh? Wait. I've been living wrongly the whole life. Like 12 to 3 o'clock, there is 4 hours. Like, wait, I have 25 hours a day? Like, huh? Like, what? What I have been living along for the past 17 years. Like, why did I know how to count time? That's because we don't count the number, we count the interval, isn't it? Like, how do you count 12 to 3 o'clock? You all count 12 to 1 o'clock, one interval in between my fingers. 1 to 2, second interval. 2 to 3, the third intervals. So if you're wondering like, I thought 4 hours, why 3 hours? Then you know what I mean now. We go for interval for time. So although I have 4 numbers, but I'm only having 3 hours, or I should say for this case, I have 5 strips. I should only go for 1 lesser, so 4 times 0.1 second. Is that all right? Right? Can you all press your calculator and tell me your final answer? Nicholas, did you press calculator wrongly? How about the rest? Is everyone okay? You all know how to press the calculator. You all got the correct answer. Okay. So 34 minus 18, it will be 16. 16 over 0.4. Yes, correct. It will be 40. 40 as CMS -2. CMS -2. Because you divide by second one more time, -2. You all know that, right? You bring this up again. That's -2. 40. There you go. That's like a usual format, or like how a take a timer question will sound like. Standard. Okay. The rest you okay? Cool. I have I think one more for you. You can try out if you want to try on your own, like without me. If you can do it, then you pretty much okay with take a timer question. Okay. So try out number 4. Yeah, I'm gonna leave that to you. We will go for another topic called inertia. So very easy topic, and quickly we will try out the question later. Okay, so everybody, Inertia, no calculation. It's a type of force. It's something that you should can feel it by yourself, right? So inertia is the tendency of an object to maintain the original position. That's according to Newton's third law, okay, which is everything in the world that has mass will follow this law of motion, which is called inertia. Things will always want to maintain its original position if there's no external force affecting it. So, well, what happened is there is two types of inertia. There is stationary inertia and there is motion inertia. Things that are stationary will try to maintain its stationary position for the rest of its life, okay? And things that are moving will try to keep moving if they can. So the only factor that is affecting your inertia is the mass. The bigger the mass, the bigger the inertia. The bigger the mass of an object, the more you want to continue your motion, whether it's stationary or whether it's moving, okay? So for instance, like when you take like bus or LRT, when the bus or LRT is not moving, you are standing there and daydreaming and thinking to go school again, like so early in the morning. Let's say if you take LRT. And then what happened is suddenly the LRT start to move, right? And then your body suddenly like, whoa, look, whoa, look, whoa. Like you suddenly didn't stand properly. That's because your body is so used to not moving. Suddenly the train move, your body is kind of forced to move together. So there's this 1 or 2 seconds your body didn't want to. So your body like, whoa, like, why must I follow? Why can I not stay behind? But too bad, you're in a train, you have to move. Okay, then while you're in a train, your body already accept the fact that your train is moving and your body is moving. So your body is under motion inertia now. So your body is so used to moving, okay? And then suddenly the train stop or brakes or turn corner, your body will be swing forward. You'll be like, "Ui, why suddenly?" Because your body used to moving and then suddenly it stopped. Your body cannot take it. Your body wants to continue the movement. Those are the feeling of inertia. If I were to bring this thing to space, it will be not never ending one. Okay, for example, if an astronaut has lost its chain or line from the space station, okay, it will be gone case. The astronaut will be all the way into the space and no one can save you anymore because there is no gravity, there is no frictional force in the space. You have internal, you have infinity of inertia. You will keep going to the end of the universe. But whereas on Earth, you can't do that because we have something called frictional force. We have something called gravitational force. Somehow you come to a stop. But that depends on your mass. Okay? So the famous question is always this swing. So we can actually turn to your exercise, page 42. Okay, let's try out one question. Okay, so this is the story. Well, when I was younger, I'm a very small kid. I was very skinny. I was like a little kid, like malnutrition kid. Okay, and I have a big friend. Okay, I have a big friend, big size. Okay, so we go to the swing. Yeah, and I'm always reluctant to play at the swing because I know for me it's not gonna be fun because my mass is small. So both of us started to swing together, and then I go like, and my friend goes like, he's having the best time of his life. I'm like, stop, no fun. Why? Because since when did we have our childhood together? Haikal, why did you put yourself into this? Anyway, since you did, yeah, Haikal, my friend were big, were huge. Did we know each other when we were younger? Well, I guess we're not too far apart. We might met in the park when we were younger. So, I did not have fun because I'll go like, he is like, you know, the trees on the side were all swinging, you know, the sand were all flying around. So he had a lot of fun because he has a very big mass. Hence, his body wants to continue swinging for a longer time. But me, as a smaller mass, my body didn't want to continue its inertia. So that's the difference, okay? I think we met during our diving session. Oh, bro, how about, tell me about that. Did you got your diving license or whatsoever? Right, so look at the time, my friends. Okay, so empty tin, 4 minutes. Empty tin for me. Me. This is me. No fun, no fun. 4 minutes, I stop by myself. My friend, okay, with sand, it took 8 minutes for my friend to stop. So you see, it takes longer time, right? Because of mass. Nope, after SPM. Oh, cool. Okay. Now also like not convenient afterwards. All right. So like everybody, write down one observation. Yeah, so you need to write down what you have here. The information is here. So means what? Means oh, my friend takes a longer time to stop. Me takes a shorter time to stop. So we need to do like a sentence to compare both. So you can kind of use all the words here. For example, time taken for the tin filled with sand to stop is longer than time taken for the empty tin to stop swinging. Can you try? Doesn't matter, you don't have to follow exactly my one, but I just need you to try and form your own sentence from here, which is your responding variable. Time taken for which is longer than which one. Okay, like help yourself, everybody. Okay, no problem. Time taken for the tin filled with sand to stop swinging is longer than the tin, empty tin, if you want to make it shorter. All right, no probleme. Okay, let's go to B. Manipulated variable. Okay lah, you all know already lah. For so many times you've been doing this kind of question. So manipulated and responding is given from your table. So manipulated variable will be me and my friend. Our mass is different. And responding variable, time taken to stop swinging. Or time taken. This one you have to, this is your responding. If your question did ask, but not here, we don't have. If your question did ask, you have to write the full one, like time taken for the tin to stop swinging. That's your responding if you want to write extra answer. So your manipulator will be mass of tin. Constant. Something here must be fair, right? No matter me or no matter my big friend, something among us or the swing, something along the swing must be fair. Okay, so make sure that me and my friend we are sitting on the same type of swing. That means correct. The length of the rope must be the same. The length of the rope must be the same, or else it wouldn't be fair. Okay, so like your constant variable will be length of the rope. Okay, length of the rope, constant variable. Okay, like hypothesis. Remember hypothesis, we always use manipulated variable and responding variable. If you can do a the sentence within these two, then go ahead. Don't have to consider anymore. The is the easiest. So can you do a the for both? Okay, so the what mass, then the what time? Like you try, okay? Okay, everybody. So manipulated okay, mass never use heavier. Never use heavier. So the greater the mass, or the bigger the mass, or the larger the mass of the tin, the longer the time taken for the tin to stop swinging. Okay, the longer the time taken for the tin to stop swinging. Is that all right? No problem. There you go. Okay, right. Last one. Operational definition. So many weeks we've been doing this already. You have to remember, you have to use your responding variables to answer. Okay. Now, your subject here is inertia. Remember, I'm not sure if you were in my previous class or not. We were talking about this method is like a 5-year-old kid asking you question Go, what is inertia? Well, to explain inertia to a kid, you couldn't just like read out the whole definition. He's not going to understand. You have to make it as simple as possible. Make it as straightforward as he can see, right? So often now we always use your responding variable to help you. So if you were to like inertia, oh crap, how do I explain to a 5? Okay, boy, you see inertia, right? You look at the swing, you look at the skinny boy and the fat boy there swinging or not. You saw or not? You saw. You see later you realize the skinny boy will stop first, and then the fat boy stop later. Then that is inertia. The time taken for the skinny and the fat boy to stop is inertia. Then we're like, oh, okay. Then you'd be like, you mean that situation, right, is to actually show by not comparing. You don't have to say like, oh, big inertia, small inertia, because doesn't matter. Both are inertia. The question is not asking which one is larger, which one is smaller, but question is asking what is just generally as inertia. So inertia is something where you can see by the time taken. If it takes longer time, means larger inertia. If it takes shorter time, means smaller inertia. There's no need to compare here. I just need to generally explain. Okay, so and the thing is this, inertia is not something, it's not a substance. You know, we're so used to write things like antibiotic is a substance or whatever it's a substance, but this is not a substance. So inertia is the effect of force. Okay. Let me type for you. There you go, everybody in your chat box. Inertia. I missed out the word is. So can you add on? Inertia is the effect of force that can be shown by the time taken for the tin to stop swinging. Okay, that's the meaning of it. Okay, no problem. Yep. So yeah, you kind of have to use your responding. So I'm using my responding, behind I'm using responding variable to explain it. Okay, no problemo. Okay, there you go. Number 6 is also repeated. If you want to try out like, okay, I want to try on my own if I can do a whole question. Go ahead, yeah. And the rest you can actually watch it in exercise video if you're keen to finish up the rest on weekends. Okay. Another half, I think that's for next week. No problem.